This video is going to be going over problems 6 and 7 from test number 3 of Calc 1. And then problem 6 is find the intervals on which a function f is increasing and decreasing. And so you get the function f of x is equal to x over the quantity x squared minus 4. You get its derivative, the quantity x squared, or the quantity negative x squared minus 4 over the quantity x squared minus 4 quantity squared. And then its second derivative is 2x times x squared plus 12 all over x squared minus 4 quantity cubed. So we know that f increases when its derivative is greater than 0 and decreases when its derivative is less than 0. So we can actually use almost a little trick here. And we can see that the top will always be negative. So because whenever you plug in a value x, you're squaring it, so that value will always be positive, but it's got a negative sign out in front of it, which will make it always negative. And then you're subtracting from that, so it's always going to be negative on top. And so on the bottom, anything you put for x, you're always going to end up squaring that entire quantity, so it's always going to be positive. So it's going to be always positive over always negative. So f prime of x is always going to be negative. So it's always going to be decreasing on its domain. But what is that domain? So if we take a closer look, we can see that f of x actually has some vertical asymptotes, and that'll be when the denominator equals 0. So x squared minus 4 is equal to 0, factors into x plus 2x minus 2, which gets you two vertical asymptotes at x equals 2 and x equals negative 2. So you can't include those in its domain. So the reason why this isn't just it decreases on negative infinity to positive infinity is because those values are not included in its domain. So basically f prime and f double prime are actually all undefined at x equals negative 2 and x equals 2, because they all have the same, they all have similar denominators, but just with different, they're just raised to a different power. So f of x is decreasing on negative infinity to negative 2 union with negative 2 to 2 union with 2 to positive infinity. So that wraps up problem 6. Now problem 7 is finding concavity and inflection points. So f has inflection points when its second derivative is equal to 0, and f can also change concavity around asymptotes. So I'll do this one step at a time here. So f prime or f double prime of x is going to be equal to 0 when its numerator is equal to 0. And since the second term of the numerator is always going to be positive, their only inflection point is going to be when x is equal to 0, because it's got that first term 2x, and when you plug in 0, that'll be equal to 0, and 0 times anything gets you 0. So x equals 0 is an inflection point of f. So as we said before, f can change concavity around asymptotes, and we said that f was undefined at x equals 2 and x equals negative 2. There were vertical asymptotes there. We said that in the last problem. So we can make a sign chart and plug in some test values. I chose negative 3, negative 1, 1, and 3. And when you plug in those values, you have to figure out the sign and that'll tell you whether it's concave up on that interval or concave down. And for f of negative 3, or f double prime of negative 3, it will be negative, so it's concave down. f of -1 will be positive, so concave up, and f of 1 goes back to being negative, so concave down, and f of 3 is positive, so concave up. So that's basically just what I said here. F will be concave up when its second derivative is greater than 0, so positive, and then concave down when it's less than 0 or negative. So f will be concave up on -2 to 0 union with +2 to infinity, and it's concave down from -infinity to -2 union with 0 to +2. So there you go. That's problem 6 and 7.